Hi, good morning to all. In my previous classes, I have already covered the lyophilic, lyophobic, and association colloids. As with lyophilic salts, formation of association colloids is spontaneous, and provided that the concentration of the amphiphile in solution exceed the critical micelle concentration. Here, the amphiphiles may be, I've already told that anionic, cationic, non-ionic, and ampholytic or zwitterionic. Here, the examples that sodium lauryl sulfate for cationic cetyl triethyl ammonium bromide, and for non-ionic polyoxyethylene lauryl ether, and for zwitterionic dimethyl dodecyl ammonio propane sulfonate. Here, a comparison of properties of colloidal sol. The difference between lyophilic, lyophobic, and association or amphophilic colloid. Lyophilic, uh, already told you, solvent loving, lyophobic, solvent hating. So difference between lyophilic, lyophobic, and association, uh, the respect of dispersed phase. For lyophilic or solvent loving colloid, the dispersed phase is large organic molecules lying within the colloidal size. Okay, and for lyophobic, dispersed phase is inorganic particles such as gold or silver. And for association or amphophilic colloid, the dispersed phase aggregates micelles of small organic molecules or ions whose size is below the colloidal size. Clear? Then comes to solvation. For a lyophilic colloid, this is solvated, but for lyophobic, little solvated. And for association or amphiphilic colloid, that's hydrophilic or lipophilic portion of the molecule is solvated depending on the medium. Then preparation. Lyophilic colloid is prepared very much spontaneous by dissolving in solvent. But for lyophobic colloid, the preparation it needs special procedure to prepare the lyophobic colloid. I have already covered the procedure process or the methods by which lyophobic colloids are prepared, like dispersion method in which the vaporization, electrical arc method, ultrasonic method, and uh, milling or grinding method is there, and the condensation method by adding the non-solvent and all total elaborately I have covered the preparation part that for lyophilic it is spontaneously prepared by dissolving in solvent, but for a lyophobic it needs special procedure like which I have already told. And for association or amphiphilic colloid, it is the preparation is spontaneous when concentration of amphiphiles exceed the critical micelle concentration. So for preparation of association colloids, we we have to reach this concentration, the critical micelle concentration at which the micelle are formed. Now viscosity. For lyophilic colloid, viscosity increased as the concentration increased. At a certain concentration, gel-sol-gel formation is occur. For lyophobic colloid, it is not greatly increased due to unsolvation. And for association colloids, the viscosity increased as concentration of amphiphiles increase as micelle number increases and become asymmetric. So when the micelles are increased, then amphiphile increase, and the viscosity is also increased. Then comes to this point the effects of electrolytes. In case of lyophilic colloids, presence of electrolytes, This is stable in presence of electrolytes, and resolvation and salting out in high concentration is occur here. But in case of liphobic colloid, presence of electrolytes it get unstable due to neutralization of charges on the particles. And for association colloids, critical micelle concentration is reduced and salting out and occur at a high salt concentration. So presence of electrolytes, critical micelle concentration is reduced and salting out occur at high salt concentration. So here the difference between lyophilic, lyophobic, and association colloids is completely clear to all. Next comes to the shape of colloidal particles. See, here is an image of colloidal particles, how it's look like. The more extended particles is greater its specific surface and the greater the opportunity for attraction. And the properties of colloids mm, as follows: sedimentation rate and OP are all affected by the shape of the particles.